Hello everyone, in this video I'll discuss the performance metrics of the machine learning algorithms. Let's start with accuracy by taking example of a cat classifier. Here are the inputs from the test set and these are the predictions made by the classifier. As you can see, the first three predictions are correct and the last two are wrong. The accuracy can be calculated by the ratio of number of correct predictions to the total number of predictions made, and this gives us an accuracy of 60%. But this accuracy may not be suitable in all the scenarios, especially in case of skewed datasets. A skewed dataset is the one which has classes with uneven instances. Let's understand this with an example. Suppose we are making a rare disease classifier and we have a test set with a size of 1000 examples. Here we have 900 negative examples, which means that no disease is present, and 100 positive examples which indicate the presence of disease. Suppose that the classifier always predicts negative class irrespective of the input, which means that the classifier has no intelligence at all. Since the classifier always predicts negative class, it ends up making 900 correct predictions out of the total 1000, giving an accuracy of 90%. This is the problem I was talking about. To gain immunity against skewed datasets, we use different performance metrics, namely precision and recall. Let's begin with precision. Precision is the measure of correctness of an algorithm's predictions for a particular class XYZ. This means that if an algorithm predicts class XYZ n number of times, the precision tells what proportion of it was correct. It can be calculated by the ratio of number of correct XYZ predictions to the total XYZ predictions made, including the correct and the wrong. Precision ranges from 0 to 1, with the value of 1 indicating that if a particular class was predicted n number of times, all the predictions were correct. Let's calculate the precision of cat classifier. Here you only have to focus on those predictions when the classifier predicted class cat, which means these two. Put the values in the formula. Since there is only one correct cat prediction and one wrong prediction, the accuracy comes out to be 50%, which means that when the classifier predicted class cat, 50% of the times it was correct. Let's move on to the precision of rare disease classifier. At this point, I'll make a minor change in the supposition to avoid the undefined output of the precision, and that is the classifier always predicts negative class, but it correctly identifies the positive class once. Since there is only one instance when the classifier predicted positive class and it was correct, it yields a precision of 100%. Whoa! This lousy algorithm had an accuracy of 90% and now it has a precision of 100%? What's going on? Don't worry, precision focuses on one half of the story about the algorithm's performance. The other half is covered by the recall, and it is the one which will debunk this algorithm. Let's dive into it. Recall is the measure of how well an algorithm is able to correctly identify instances of a particular class ABC. This means that if a test set contains n instances of a particular class ABC, the recall tells what proportion of it is correctly identified by the algorithm. The recall is calculated by the ratio of number of correct ABC class predictions divided by the total number of ABC class instances present in the test set. Recall also ranges from 0 to 1, with the value of 1 signifying that the algorithm was able to correctly identify all the instances of a particular class. Let's calculate the recall of the cat classifier. Here you only have to focus on the instances of cat class, which are these two. Since the classifier only made one correct cat prediction out of the total 2 cat instances in the test set, the recall comes out to be 50%, which means that the classifier is able to correctly identify half of the instances of the class cat. Here comes the most interesting part, which is exposing of the rare disease classifier. Since the classifier correctly predicts the positive class only once out of the total 100 positive class instances in the test set, the recall comes out to be 1%. Finally, the hollowness of this rare disease classifier has been proved. Moving forward, we have the F1 score, which combines precision and recall to give an idea about the overall performance of the algorithm. It is calculated by the harmonic mean of precision and recall, which gives more weightage to the smaller values. The benefit is that if any one of the precision or recall is low, it will pull the F1 score down, and we know that there is something off about the algorithm. F1 score also ranges from 0 to 1, with 1 being the best score, and to approach it, we need both precision and recall high. This is the F1 score of the rare disease classifier. Notice that how the small value of recall pulled the F1 score down even when the precision was 100%. Now we know that our goal is to achieve high precision and high recall. First of all, let's see how we can achieve high precision. High precision implies when a particular class is predicted, most of the time the prediction is correct. And to achieve this, you have to increase the threshold or confidence level on which you predict that particular class. Let's understand this with an example of logistic regression. Suppose you predict class 1 when the output of the sigmoid function is greater than 0.5 and class 0 when it is less than or equal to 0.5. To achieve a high precision for class 1, you may want to increase the threshold from 0.5 to maybe 0.9. And what this will do is make the classifier predict class 1 only when it is very sure, and this will increase the likelihood that the predictions for the class 1 are correct, thereby increasing the precision. However, this will render low recall because the algorithm will miss out or misclassify a lot of instances of class 1 with relatively low confidence value or low output of the sigmoid function. To catch such instances, you may want to decrease the threshold value. This will increase the recall but lower the precision. As you can see, there is a trade-off between precision and recall. This begs the question, how do we decide between high precision and high recall? Well, this totally depends on the application. Suppose you are making a classifier for a life-threatening disease, then you may want to keep the recall high because we don't want to risk the life of the patient by missing them out. So we will consider the treatment even if we have a low confidence. On the other hand, if you are making a classifier for a benign disease which has an expensive or risky treatment, then we may want to keep the precision high because we only want to go for the precision if we are very sure. Also, we can afford missing out a patient because the disease is benign. Finally, other applications may require a golden balance of both precision and recall. Yeah, so that's all. In the end, I would love a feedback. How do you like my presentation? Was it understandable? Is there anything you would like me to improve? Also, if you have any questions, feel free to drop them in the comment box. I hope this was helpful. Thank you very much.